is talking about a rate of change. Just want to tack on to the lesson from Monday a few additional things. You know, we can even find the average rate of change of a function that's not linear. And we do that by the very same way. As long as we have 2 points, we can find the rate of change. We just subtract y's over the x's, delta y over delta x. And so with a nonlinear function, I might ask you to find the average rate of change over an interval. So I'm just only going to look at a piece of that function and say find that average rate of change. Well, let's look at what that might look like if it were a problem that I would give you. So I've got a table. And this is a nonlinear function. If I were to graph this, it would not be a straight line. But I'm asking you to find the average rate of change. Okay? Over the interval of 1 to 3. That's pretty important. So I'm going to look at that interval. I'm going to say, okay, I'm just going to find the average rate of change. So you might want to jot that table down just in a little chart. Really, the only thing that's important in that table is the interval of 1 to 3. Okay, and so at 1, my y value there is 4. And at 3, my y value 16. That's the only 2 points that are important because I'm finding the average rate of change on that interval from x being 1 to x being 3. So I have 2 points there. The 2 points are 1 and 4 and 3 and 16. To find any rate of change, I just need 2 points. All right, so my average rate of change then is going to be 16 minus 4. The difference in my y's over the differences in my x's, 3 minus 1. 16 minus 4 is 12. 3 minus 1 is 2. So my average rate of change is 6. Now it's an average. It's not perfect, just an average. So I would say, well, over the interval of 1 to 3, and I would say it this way: 1 is less than or equal to x, less than or equal to 3. The average rate of change is 6. So if you're asked to find the average rate of change, all you're doing is finding the rate of change between a couple of points on a nonlinear graph or a nonlinear function. Let's see what that looks like in another example. You know, we see this one in a table. Remember, when we talk about functions, we want to look at them multiple ways, as in equations. We want to look at them in tables. We want to look at them in graphs, mappings, you name it. We've got lots of different ways of looking at it. So let's look at it in terms of a graph. Now this one says to find the average rate of change over the interval of 1 to 4. Well, all I need to do is I need a point for 1, and I need a point for x is 4. But But I need to look at my graph to figure that out. In fact, finding the average rate of change or just finding the rate of change, I just need 2 points. I just look at the graph and find them. So if I go out the x-axis 1 and go up to see where it intersects the grid, it intersects right there. That has a y value of 1. So at x equals 1, so is y. Y is 1 as well. Check it out. At x is 4. Look to see where it intersects. At x equals 4, it intersects right here. That happens to have a y value of 2. So to find the average rate of change, that's going to be 2 minus 1 over 4 minus 1, or 2/3. Make that 1/3. 2 minus 1 is 1. So my average rate of change is 1/3. So I'd say over the interval of 1 to 4, the average rate of change is 1/3. So whether I'm looking at a graph or a table, finding it's pretty easy. The interval tells me which 2 points to use. If I have 2 points, I can find the rate of change. Delta y over delta x, subtract the y's over subtracting the x's. So, we look at these problems in several different ways. We've looked at it in tables. We looked at it in graphs. Let's look at it in a real-world problem that's what we typically would call, say, a word problem. That's what we'll look at with our next example. Give me just a second to finish copying those down. All right, I think we're all there. So a ball is thrown in the air. We want to find the average rate of change here from this function. It's thrown in the air and has a height of h of t is equal to negative 16t squared plus 50t plus 3 feet after t seconds. Well, what are the units of measure for the average rate of change here? Well, that's simple. That's just feet per what? Per seconds. Because it's measured in how far it goes, how high, in relationship to time. Typically, time is always my x. Okay, so it's feet per seconds. All right, so we want to find the average rate of change between 0. So here's my interval, 0 and 2. I'm going to make a t-chart using this function. I need to know what is my function at 0, what is it at 2. So I take the function, it's h of t, make a correction in my t-chart. I said f of t, let's make it h of t is equal to negative 16 t squared plus 50t plus 3. And the first thing, yes, ma'am? I can't understand.
Brittany said these are going to be on YouTube.
Yes, but unless we have an internet outage like we did last period. But yes, it will be on YouTube. Yes, ma'am. Try to post those daily. So let's go back to this h of t. So we want to evaluate it at 0. I love 0 because it's easy. Negative 16 times 0 squared plus 50 times 0 plus 3. Here's the deal. 0 squared, 0. 0 times 16, 0. 50 times 0, 0. So the only thing I have here in this problem is f of 0 is equal to 3, because they're multiplied by zeros, it just kind of disappeared. So at 0, my y value is 3. Need to do the same thing with 2. It's negative 16 times 2 squared plus 50 times 2 plus 3. So 2 squared is 4. So this is negative 16 times 4. Plus 50 times 2, which is 100. By the way, I have written it before power should be squared. I apparently was thinking ahead. So a negative 16 times 4 is 64. Plus 100 plus 3. 100, negative 64 plus 100 is negative 30, or rather positive 36. 36 plus 3, 39. So at 2, then my function is 39. H of 2 is 39. Now, you could put that in your graphing calculator and press second function table and do the math for you. Y'all know that. So it's asked us then to find the average rate of change. So to find the average rate of change, I have 2 points. I've got the 0, 3, and I have 2, 39. Okay, so to find that average ROC, rate of change, now take 39 minus 3. That's my delta y over 2 minus 0. 39 minus 3 is 36, divided by 2 is 18. So over that interval of 0 to 2, the average rate of change is 18 feet per second. So whether it's even a nonlinear function, if we define a small piece of it, a small interval, then we can find at least the average rate of change over that interval. And so you may be asked to do that. Remember, when you're finding rate of change, it's just 2 points. Find 2 points. And then take those 2 points and find the difference in y's over the difference in x. We call that delta y over delta x. Which brings us to what we want to look at for today. You've had this before. In fact, if I say slope-intercept form, many of you will say y equals mx plus b. You've heard that 1,000 times. You know what that means. So it's not anything really new. And it fits in with our standard of when we talk about different forms of the equation of a line, they help us to determine key features. They help us to understand what intercepts are and even maximum or min. We won't have that so much with a linear function, but we will with other types of functions. So we want to look at that slope-intercept form. Now, write this down, please. The line has a slope m and the y-intercept we call b. It's at 0, b. So slope-intercept form is this y equals mx plus b. M is our slope or our rate of change. And b is a y-intercept. Now, it's really important to know what a y-intercept is. A y-intercept, when giving a coordinate plane such as the one I just drew, the y-intercept is where the line, the graph of the line, crosses or intersects the y-axis. Now, let's say I mark this off by 2's. So here we go. It's 1, 2, 3, 4, 5, 6, 7. I would have to look at that and say, okay, this y-intercept here is at, if I'd drawn it a little better, I kind of missed it, yes. That y-intercept is on the y-axis at 2. Notice that that point has a x-coordinate of 0. Here's the deal. Listen very carefully. This is so amazingly simple and so amazingly important. The y-intercept will always have an x-coordinate of 0. There's no way that you can cross the y-axis and x not be 0. It's just not going to happen. You can't do it. So always, if the point crosses the y-axis, x is 0. Notice I put that up here, okay? Notice it's in your definition. The y-intercept is 0, and then whatever that y-coordinate is. If you see a point, hint, listen, because we're going to see an example of this in just a minute. If you see a point that has an x-coordinate of 0, you found the y-intercept, because whatever y is where it crosses the y-axis. It can't even cross the y-axis at 0, 0. Y0, x0 crosses at y at 0. If it's 0, 5, it crosses at 5. If it's 0, -3, it crosses at -3. So, the slope-intercept, notice in the very name, slope-intercept describes our form of the equation. Here's the slope. Here's the intercept, the y-intercept. Just the very name of that form of the equation, slope-intercept form, tells us what that form of the equation tells us. It gives us a lot of information. Well, look at this one. I want to write a slope-intercept form of an equation. And I'm told that the slope is 3. And I'm told that it includes this point 2, 5. Okay? So I know those two things. In order to write the equation line in slope-intercept form, I need to know the slope and the y-intercept. Those are the two things I've got to know. So do I have the slope? I do. What is it? What's the slope?
3.
Thank you. Do I have the y-intercept? Well, no, I don't. Because I don't have a point that says 0 something. But using y equals mx plus b, I can find it because for m, I can put in a 3. I also have an x and a y. So I can plug the x in. It has a value of 2. And I can plug my y in over here. It has a value of 5. And then just leave my y-intercept there as plus b and solve it for that y-intercept. So if I solve it, it's just 5 equals 2 times 3, which is 6, plus b. I already know to subtract 6 from both sides to get b by itself. And so 5 minus 6 is negative 1. So my y-intercept then is what? It's negative 1. Yeah. Now remember, the goal is, questions ask me to write the slope-intercept form equation. So here we go. This is the fun, easy part. Y equals, what was the slope? 3. X. What's a y-intercept? Plus negative 1. Y equals mx plus b. And I can write that even a little simpler. I could just write 3x minus 1. I don't have to put 3x plus a negative 1. So that's all there is to that. Is that hard? No, you don't know how to do this already. Y equals mx plus b. You know two things. You got to know your slope, your y-intercept. You can write an equation. Let's look at another one. Now, so far, only one person today has answered this question. So here comes the question. Let's see if y'all are the sharpest of the day. I have to have, well, write the equation in slope-intercept form of this line that passes through 0, 5. I have to have a slope. I have to have a y-intercept. They gave me 2 points, 0, 5 and 2, 13. Is the y-intercept up there? Look.
Yes, it is.
What is it?
5.
Wow, good. How do you know that, Luke?
Well, the x-coordinate is 0, which means it has to be the y-intercept.
Absolutely. I'm so proud. I mean, like, all day long, you're the first to have said it that cleanly, that clearly, and done that well. So, look at this. We've got to find the slope. All we have to do to find the slope or the rate of change is we have to have 2 points. We got 2 points. So, we're good to go. M is equal to change in y, 13 minus 5. Over change in x, 2 minus 0. 13 minus 5 is 8. 2 minus 0, 2. So my slope is 4. Now, to write the equation, I have to have 2 things. Those 2 things are the slope and the y-intercept. I've got them now. So my equation is this. Y equals 4x plus 5. And that is all I need to do. Done. So I can write the equation of any line as long as I know the slope and the y-intercept. If I know those 2 things, I can write the equation. If I don't know those 2 things, it's my job to find those 2 things using the tools I have been given already. If I have 2 points, I find the slope. If I don't have 2 points, but I have the slope and maybe a second point, I can find the y-intercept using the equation, just plug in x and y and n. Let's look at another example. Okay, in this case now, not only do I want to take this 2x plus 3y equals 6, I want to write it not only in slope-intercept form, but then I also want to graph it. Here's the thing, graphing is easy. Just like to find slope, I just need 2 points. To graph, all I need is 2 points. Or I can have 1 point and use the slope or the rate of change to find a second point, and then I can graph. Then I have my 2 points. To graph, I need 2 points, period. So to put 2x plus 3y equals 6 in the slope-intercept form It's just solving it for y, which I've been doing all along. I know that I have to move my 2x. I can do so by subtracting from both sides. And when that cancels, so I'm left with 3y equals negative 2x plus 6. Now, to get y by itself, I've got 3 times y, so what do? I have to divide by what? Say it. Divide by what?
3.
Yeah. That way my 3 cancels out, my coefficient on y disappears. I'm left with y is equal to negative 2/3 x, and 6 divided by 3 is 2. So looking at this equation, remembering y equals mx plus b, I can see that my slope is negative 2/3, and my y-intercept is positive 2. I don't have 2 points yet, but I've got 1 point. Here's my first point. Okay, now this is set off by 2s. 2, 4, 6, 8, 10. So my y-intercept is right here at 2. That point is 0, 2. I know my x-coordinate is 0, and my y-coordinate is 2. Okay, so remembering that slope, rate of change, is rise over run. I know if I start here and I run forward 3, okay, so remember these are marked off by 2. So in order to run forward 3, I need to go 2, so I go to the halfway mark right there. So that's a run of 3. And then I have to go down negative 2. Negative 2, rise means up or down. Negative means to go down. So I have to go down 2. And so that's a rise of, I guess I really should say fall. It's a fall of negative 2. And I arrive right here at this point. Now that point is negative 2, and y just happens to be 0. If I connect those 2 points, I'll graph the equation of that line. Simple, isn't it? Easy. Anybody can do it. We'll look at one more example today in the notes that you're doing. And once we get this example, you'll be ready to try some on your own. Now, we look at these in tables, we look at them in graphs, and sometimes we look at them in words. And so this is kind of a table in words. It says we're going to identify the slope of the y-intercept to represent this linear situation and interpret what they really mean. Okay? And then we're going to write an equation. Okay, so looking at that, do I have a y-intercept? Can you tell me? Well, let's just read the problem first. I do have one. We'll come right back to it. My local club charges an initial membership fee as well as a monthly cost. The cost is C in dollars as a linear function of the number of months of membership. Find the cost of membership after 4 months. So ultimately, we've got to figure out what's it cost 4 months. You nod your head yes. What is my y-intercept?
$100.
Yep. Lisa got it right. Luke with her voice. There we go. My y-intercept here is $100 because that's at 0. Okay? Now, I don't have a slope, but I have 2 points. I can just use any of the points I have on there. I'm going to use the smallest points because it makes my math the simplest. So I can say, well, my slope here is 277 minus 100 over 3 minus 0. 277 minus 100, 177. 3 minus 0, 3. What's 177 divided by 3? 59, is that right?
Yeah.
Yes, okay, somebody divided, so 59. Okay, so let's interpret this. What is the y-intercept? It is the that's not right. Intercept. Let me spell it correctly. The y-intercept. Anybody know what that means? What does it represent on the graph? The y-intercept is what? It's the fee. Okay? It's the initial fee of $100. In other words, at 0 months, just to join the club, I got to pay $100. That's what the y-intercept is. What's the slope represent? The slope is how much it's going to cost per month. It's the fee of $59 per month. That's what the slope represents. That makes sense. For each month, I'm going to pay another $1,500. That's what the slope is represented here when we found it. So it asked for me to find a membership fee after 4 months. Well, y equals mx plus b. I could say f of x equals 59x plus 100. Okay, remember the intercept is 100, the slope is 59. And so to solve that, to find what they're asking me to find, then all I have to do is, we'll know what it costs after 4 months. So plug a 4 in for x, 59 times 4 plus 100. So what's 59 times 4? I'll race you. I think it's 236.
Yeah.
Ah, good. 236. A calculator you got's not bad. Plus 100 would be 336. So 4 months would cost $336 total. Works every time. So we can use that slope-intercept form, one, to identify the slope, to identify the y-intercept. We can use the slope-intercept form to solve a problem by writing an equation using the slope that we found and the y-intercept we found and solving it for what we don't know. We can use it to graph. And we can also use it just to complete a table. So that's the purpose and the reason we study that. And we need to just remember when we say slope-intercept, that's what it's giving us. It's giving us the slope and the y-intercept.